In this assignment, we will basically be modeling a fairly simple portal frame, and we will be modeling it using tapered elements, which are commonly used with the pre-engineered buildings. Now, we've been given some notes. The columns are tapered profiles, starting with a height of 300 and ending with a height of 1200. So we can see that over here. If we zoom in, the columns are start with a total height of 300, and the top height is 1200. Similarly, the web thickness of the columns is 10 and the flange thickness is 20. The first roof beam is tapered with H between 1200 and 400. So that's this roof beam over here. This one, it's basically the start is the same as the end of the column, 1200, but then it tapers down to at a certain distance of 8433 millimeters from this point along the roof slope, and it comes down to 400 millimeters. And from that point onwards, the next profile is basically a straight profile, 400, and starts with 400 and ends with 400 as well. The height of the column is 8 meters at that point, and the total height of the building at the apex point is given as 12 meters, whereas the total span is given as 24 meters. So this is basically what we will be modeling using the tapered sections in COMOSYS. So here I've created a basic model with a grid of 24 meters in the x direction and nothing in the y direction. And we'll just model our column on this grid. Now to enter a tapered member, what you do is you just enter a normal member first. So I'm going to enter a normal column like that. I want to rotate the column direction. So I want it oriented like that. And then what you do is you can also, let's change the height to 8 meters like that. And once you have the basic column inside, you click on this button over here. And when you do that, it'll take you to the database where you can select other profiles as well. But over here you have this option on the right hand side of there's a tab called tapered. And if you click on it, there might be something existing in there from the last usage. You can delete that section to start off from scratch. So what you do is you create, it's not from the database, the method is manual. And since the H is the varying direction, you select this option of H, alignment would be along H. The type would need to be selected as I profile because this is an I profile. Some other options are also supported. And then it asks for the starting H value and the ending H value. So in our case, it was 300 and the ending H value, let's go back to the example. The ending H value was 1200. The start was 300. The end was 1200. So we can say that our ending H value is 1200, like that. The flange width was given as 200. The web thickness was given as 10 and the flange thickness was given as 20. At the start as well as the end, you'll basically enter the same values for the start and the same values for the end. Only the H starting and ending values will vary. Now, there is a relative length option over here and we need to keep it at 1. And the reason why we have it is because theoretically, you could use this same mode of entry for tapered members to create a multiple taper as well, in which case the relative distance would go, let's say, from 0 to 0.3, from 0.3 to 0.6, and then to 1. Maybe if you want to break it down into several portions. But in our case, we'll keep it at 1. And making sure that everything is correctly done, what we will do is we will say add section. And when we say add section, it's going to actually create a name over here. This is the name of which the tapered section will use. I 300 is the starting value, 200 is the flange width, 10 is the web thickness, 20 is the flange thickness, and the ending values are 1200, 200, 10, 20, and these ones are related to the relative lengths and the moment of inertia variations, which you don't need to worry about. So once you've selected that, you can just select that over here and say select tapered member, like that. So it brings that name over here. You could have just written it directly, but obviously it's complicated to do it like that. So that's why you go in there and bring it from there. And once you've done that, you click on the OK button. Now, if you notice, it's created a tapered member. And these tapered members, because they're unsymmetrical, they will at times require some modification from the original. So in this case, let's select the column and press Ctrl W twice, and we get it to the position where we wanted this face to be vertical. If you look at it from the side, like that, you can see now that it is exactly aligned. This face is aligned vertically, whereas this is the inclined face. And this is exactly what we wanted. Now the beam is going to be entered in a similar way. The only difference being that it is, if you go back to the assignment, the beam is entered at a distance of 8433. That's along that line. So what we can do that is we can first just enter the whole beam and then break it from this point, and then modify the two members directly. So now let's enter that beam. We can just enter a normal beam, like I said, just like we did with the column. We entered a normal column and then modified it. So we enter a normal beam, we click on this point, and we know that the end point, the apex point, is at a distance of 12 meters from the midpoint. So what we can do is we can hover over the midpoint of the grid, press enter and say DZ 12,000, like that, and we'll basically get a beam entered like that. Now we need to break this beam at a distance of 4216 from this apex point. Just keep this number in mind. What we can do is we can go to our edit menu, go to the extension point, click on the shift key, say minus 4216 to create a point over there, and we can say from here to here. We can't see the point because the points are turned off. So this is where I want to break that beam, and then I can select that beam, right click, go to the frame editing and say break frame, and then click on this point. And when I do that, basically that beam will be broken into two parts. If I select this one, you can see it's 4216, this last part, and the other is whatever it needs to be. Now, the beam parameters, the tapered beam parameters, are quite similar to the column, other than that it starts off with 1200 but ends at 400. Just keep that in mind. The other parameters of the web and everything are the same. So we go back to the model, we double click on this beam, click on this button as we did last time, go to the tapered option, and we once again choose the H direction, type is I. The starting value is 1200 for H and the ending value is 400. The B's are 200 at the start, 200 at the end. The S was 10 and the T was 20, T being the flange thickness. Relative length was 1. So we have I section, H direction, just control the numbers. Once you're okay with, say, you say add section, and you see the section is given over there. Now just select it and say select tapered member. It comes over here, and now you can click on the OK button. And now you will see that because these are unsymmetrical sections, sometimes you will need to, you can try Control W like that. If that's not working, you might need to rotate it. So you can press Control Q, twice, change the rotation, because the algorithm for the coordinate system of these members are different for columns and beams. Therefore, it might be that the column Y direction is different from the beam Y direction. So you might need to click on Control Q a few times or Control W a few times to align them. Because they're unsymmetrical, that's kind of unavoidable. So we've got the beam basically where we want it to be. This one, of course, is not where we want it to be, and we continue with modifying that now. Since this section is not really a tapered section. We could also enter a normal section with the correct parameters, but we'll do this one using the tapered sections as well. So we go back in there, we go to the tapered option, we delete the existing one, which was from the last command. I remains there, 1 remains there. This one will start at 400 and end at 400 as well. The other parameters will be the same. This needs to be I, this needs to be 1. Just say add section, select that, select tapered member, and say OK, and we will get the I-beam. Because since this is the same, this is kind of symmetric, therefore we did not need to do the control Q. If we press Control Q twice, we'll bring it back out, like we'll give it the same coordinate system as this one, as the other one, and maybe that could be preferable in some cases, but it would work both ways since it's not really an issue. Now, once what we've done is we've basically entered half the structure, and at this point we need to mirror it across to the other side. So what we do is we select all the elements, maybe just select the profiles, that's better, not the points. And then we say right click and we say copy special mirror, and we select the midpoint of the grid. And for the second point, we just give any point in the Y direction. So I'm going to hover over that point and say dy 100 like that. So it's going to create the mirror plane over there. And then I say run, and I get my mirrored pre-engineered building structure on the other side as well. And this was basically what the assignment was wanting from us. All these informations have been followed. We've done the 4216, we've done the 24,000, the 8,000, the start and end values and everything. So it's quite easy to enter your profiles like this. There are other ways of doing the same thing. You can actually use plates instead of profiles, and that will be a separate assignment. But with this option, it's quite easy to enter any kind of a tapered member which you want.